Hi everyone. We're going to practice some combination problems in this video. And what do we mean by that? Well, when we learned the rules for sig, figs, and arithmetic, we learned a rule for addition and subtraction. Remember, we were paying attention to decimal places there. And then we learned another rule for multiplication and division. Remember, we pay attention to sig figs there. So we did some examples where we added and subtracted. We did some examples when we multiplied and divided, but we never combined all these different operations and these two different rules into a single problem. That's what we mean by combination. So what we're going to have to do is keep track of the sig figs as we go, or in other words, follow the rules as we go, and then don't round until the very end. So let's try one. So here's a problem, and notice that we have subtraction in the numerator, and then we've got this division. So if you were to ask me, how many sig figs should be in my final answer? I would say, well, I can't tell by looking at it. I've got to follow the rules as I go, and then I'll tell you at the very end. So let's deal with this numerator. Notice that we're subtracting. What are we paying attention to? We're paying attention to decimal places. So I've got 2 decimal places here, 2 decimal places here. I better end up with 2 decimal places in my answer. Let me do this on my calculator. Oh, and you know what I got? I got 5.1, but I need 2 decimal places, so I'm going to add a 0. So I've taken care of the numerator. Now we're going to finish the problem and divide by 1.8000. So now, since I'm dividing, I'm no longer paying attention to decimal places. I'm paying attention to sig figs. And I've got 3 sig figs here, and I've got 1, 2, 3, 4, 5 sig figs here. My final answer better have 3 sig figs. So let's do it. When I do this arithmetic on my calculator, I get 2.83333. That 3 just keeps repeating. But if I need 3 sig figs, I get 2.83 final answer. So I ended up with 3 sig figs and 2 decimal places. Isn't it kind of interesting that none of the values in the original problem had 3 significant figures? So you've got to follow the rules as you go. Let's try another one. Okay, so it looks like we're going to have to follow the rule for multiplication here, and then we're going to have to subtract. Again, if you ask me to look at this problem and tell you the number of sig figs, I can't because I have to follow the rules as I go. So let's do this arithmetic here. I am getting 3,510, and I know that since I'm multiplying, I'm paying attention to sig figs. So my answer better only have 2 sig figs, but I'm not going to round until the very end. So some students simply draw a box around the significant figures, but I usually just convert mine into exponential form. So I might rewrite this as 3.510, and I wrote the 1 and the 0 as subscripts because they're insignificant times 10 to the third. So if you want to write it in exponential form, you can. If you just want to leave it alone and draw a box around the 2 sig figs, you can do it that way as well. Let's do the arithmetic here. I'm getting a rather large number, 34,037.1. But again, when I follow the rules for sig figs, it looks like I have 4 sig figs here, 3 sig figs here. So really, only these 3 digits are significant. Again, if it were me, I would just write this in exponential form. So that would be 3.40, and these 371, are insignificant, times 10 to the 1, 2, 3, 4. So now I've taken care of the multiplication in parentheses. Now I've got to do this subtraction. So now I'm following a different rule and I'm paying attention to decimal places, but remember, I've got to convert these exponents to the same power. So I usually convert to the higher power. Let me rewrite this as something times 10 to the fourth. So 10 to the third converted to 10 to the fourth means I've multiplied by 10. I've got to divide this by 10. So that's 0.35 with an insignificant 10. And now I'm going to subtract this number. I'm just going to leave it alone as 3.40 with an insignificant 371. So now I'm paying attention to decimal places. 2 decimal places here, 2 decimal places here. So my answer better have 2 decimal places. And let me do this arithmetic on my calculator. And when I do this on my calculator, I am typing 0.3510 minus 3.40371. Again, I'm including these insignificant digits in my calculations because I don't want to introduce any rounding errors. And I got negative 3.05 with an insignificant 271, which I would round as negative 3.05 times 10 to the fourth. Final answer. So I hope you try some of these combination problems on your own. Thanks for listening and good luck.